Hi to all. In this brief video, we will be solving a three-step binomial tree. And the whole objective of this exercise is that acquainting with this tree will make the exercise of solving a two-step tree much simpler. And at the same time, you will acquaint with how the tree works and how to solve it in a much simpler way. So the first thing when we're solving the tree is that we have an initial stock price. We have it here. And that initial stock price is given with the problem. So basically, I will start filling all of the stock prices, starting with this one, which is the stock price today, and that is node A. So I just type it here. Now, as we move forward in the tree, two things can happen. So as we move forward from today to the next step for the next period, which is t+1, and the length of each one of these steps, we can assume different lengths according to the problem. But as we move forward in time, one or two things can happen. We can end up in the good state of the world here, so the stock price moves up, or we can end up in the bad state of the world here, so the stock price moves down. Whenever we move up in the tree, we're moving up by this factor 2. And whenever we move down in the tree, we're moving down by multiplying the stock price by this factor 0.5, so half of whatever the previous price was. Now, one quick trick is that we could just multiply this previous step by this up factor, and then we lock this up factor cell reference, and so we can just copy, Control C, you can just copy, or you can copy here, and once you copy, you can just paste it in every node where you have a lower node in the previous period, right? For example, we cannot do it here because we don't have a node in a lower level, right? So, but we can use it here, and that's it. Then the other possibility, let's go back to node A, is that we end up in the bad state of the world, which means, well, the stock price goes down. If that happens, we just multiply the previous price by the down factor, and then let's lock this by adding these dollar symbols once again, and then that's it. So now, as we continue moving down, I can just copy and then paste these this formula. If we look at the last of the formulas, we are seeing that, yeah, what this is doing here is multiplying the previous price by the down factor, so it's moving down. Now, we could have ended up, for example, with this price in two different ways. The way we did it was multiplying the node C by the up factor. But what if we just multiply node B by the down factor? Well, not surprisingly, we would end up with the same price, and that's how, well, this tree has an internal consistency, and it is because U and D are the same at every one of the nodes in the tree. Once we have the stock prices, right, then the next step is to calculate the intrinsic values at the terminal nodes. So we go to the terminal node, which is at the terminal time period, which is a t+3, and we solve for the intrinsic value of each of a call option in this case in each one of these scenarios. Now let's remember what is it that we are seeing. We are starting at node A, and then, for example, node G, it simply means that the stock moved up. We ended up in node B. Then the stock moved up again. We ended up in node D. Then the stock moved up again. So it's every single time we ended up in the good state of the world. However, node H, there are a couple of different ways through which we can end up in node H. And one of them is, well, we ended up in the good state of the world in here. We moved from node A to node B, then to node D, and then we ended up in the bad state of the world, which is the stock went down, and we ended up in node H. but at the same time, we could have ended up in the bad state of the world right at the beginning. So we moved from A to C, and then of course the stock recovered. So we're moving up to node E and then to node H. So now back to the intrinsic values. Now we only need the intrinsic values in this terminal node, but for simplicity, I will solve just for completeness. I will solve the intrinsic value in all of these nodes. So the intrinsic value of a call option, it's simply max of the stock price minus the strike price. And let's lock this strike price so then we can copy that formula in all of the other cells, or 0. So by now we are already familiar with that expression. We can just calculate this as the intrinsic value. If we double check it, yeah, the stock is 240 and the strike is 20. So of course, intrinsic value is 220, which is the gain basically, or the value you could obtain if you decided to exercise this option at time t plus 3. Now that we have this formula, we locked this by adding these dollar symbols, or by we can place the cursor anywhere in the cell reference and just press F4. We should see these dollar symbols, but if that is not working on your system, you can just type these dollar symbols yourself. I'm repeating this just in case somebody's not doesn't remember. So now we can copy. I have just pressed Ctrl C, or you could copy manually here, and then we can just paste Ctrl V, Ctrl V as in Victor, or you can press. You can select paste here, right? But I'm gonna choose Ctrl V in each one of these green cells because of how I have I have arranged the tree following the same pattern. I can just copy and paste everywhere, and this is working. And it will work for all of the formulas because everything is arranged symmetrically. Now we have the intrinsic values, but once again, we only need the intrinsic values here. At least if we're dealing with an European option, and if we're dealing with an American option, and then we want to double check if we should replace the price for the intrinsic value in any of the nodes, but that is not the case here. And we're not concerned about, we're not doing that. We're not checking if we should replace or not any nodes. So conventionally, we just need the intrinsic values here. Now, once we have the intrinsic values, one last step is to solve for the price of the call option at each one of the nodes. And we begin by the terminal node. Now, at expiration, this is what the terminal node is. The price of an option is exactly the same as the intrinsic value. So I'm just going to use this very simple expression, which is just make it equal to whatever the intrinsic value is. As a matter of fact, we shouldn't even use this. But for completeness, it's better to do this. And basically, we're just getting this the same as we already had in the intrinsic value. Next, now we need to use this general pricing formula, which is probability of a call option moving up times the price of the option if the option moves up, plus 1 minus probability, and so on. You have the formula on canvas. Let's get those probabilities because now we need them, right? So we can get those probabilities with the formula for probabilities. You go to Canvas, you see this formula in the other videos for the single-step binomial tree, for the two-step binomial tree. I go over these formulas in more detail, but for now, I will just do it a little bit faster, which is 1 plus this risk rate minus the down factor, and then I put all of this in a parenthesis, and I'm going to divide by up the factor minus the down factor, and there we go. So that is the probability of a stock moving up, and of course, because of that, it is also the probability of the call option being in the good state of the world And then 1 minus this is the probability of a stock moving down or ending in the bad state of a world. At each one of the nodes, the probability is the same. And of course, it is also the probability that the call option, I'm talking about this one now, will end up in the bad state of a world. Once we have the probabilities, then the formula for pricing here in these nodes, and this node is simpler. So now let's keep in mind the distinction that here at terminal node, we do not use this pricing formula. We do not use the probabilities. So we solve for the price of the option here simply by recognizing that the price is the same as the intrinsic value. Then we start solving the tree backwards. When we solve the tree backwards, then we use the pricing formula, right? And this is going to be probability of the stock and therefore the call option moving up times the price of the call option in this good state of a world, then plus 1 minus the probability of going up, which is probability of going down. And if it goes down, then we multiply this by the price of the call option if we end up in H, which is the bad state of a world if we are currently at node D. Now, once we have that, basically we have a weighted average probabilities. So we have an expected value of our option in the next period. And because this is the expected value of the option in the next period, we need to get this to present value. And we do that by dividing by 1 plus the rate. Now, in doing this, we're just assuming that this is the rate for that holding period for that 3 month or 1 month step for whatever the duration of each step in the tree is. So we don't need to make any adjustment. We're assuming this is for simplicity, we are just assuming that. Now let's lock the probabilities and the rates, pressing F4 or adding these dollar symbols here, adding the dollar symbols to the probability, adding the dollar symbol to the probability. And we do not lock the price if the call goes up or the price if the call goes down. We keep those values without locking them so they can update as I'm going to copy and paste. And then there we go. Let's remove a couple of and keep only 2 decimals. Now we copy and we can paste in each one of these in each one of these nodes. So if we quickly paste in each one of the nodes, we end up with the price, and I am doing the same even in node A. So let me go back, right? So we solve for all the call prices in these nodes in period T plus 2. The nodes are D, E, F. Then we continue moving backwards, and what we're doing is we're copying the formula, we're pasting it here in node B. If we are solving for node B, basically the good state of a world is D. So now we are not concerned about intrinsic value, we are concerned about the price of the call option. Okay, and the same thing, if we end up in the bad state of a world, we're in B, we end up in E, then this is the price. The price we would get is actually this one, and in the good state of a world, once again, it's this one, right? So now we just copy to node C, and basically what we're doing is, if I do it like this, you can see it clearly. We have probability of going up. If it goes up, we end up with 13.97. If the call option, if the stock goes down, then we end up in the bad state of the world for the option 2, we end up with 0. And then we divide that by 1.05. We're simplifying, assuming that the rate is the same duration as the length of the steps of this tree, which should not be the case, but we are assuming it for simplicity. And then finally we copy. We're just copying and pasting. We copy it in the last of the nodes where we are using this prices we have achieved, we have obtained for nodes B and C. So once again, we're not considering the intrinsic values green. We are considering the call prices, which are in blue. The only nodes in which we consider the intrinsic values are D, E, and F when we look at the possibility of the stock moving up or down. And it is because the price of the call option at this node is exactly the same as the intrinsic value. If we notice that, that's what we have done, right? So just to summarize, and I will delete this just so that we can summarize step one. Step one, when you're solving the tree, is to get the stock prices. I'm not sure if these steps are going to match what I have, the steps I have mentioned in previous works, but if they're not perfectly matching, they're going to be quite similar. Then step two, after you get the stock prices, is get the intrinsic values at the terminal nodes, G, H, I, and J. Then step three, solve the tree backwards use general pricing formula, and basically that covers it. Oh, well, I'm going to name this step 4 because before we can use this formula, we need one last step, which is one step before, which is get the P and 1 minus P, right? Because we will need that if we want to use the pricing formula. So that's how we solve this 3-step binomial tree. I hope this is helpful. And once again, as we continue to add steps to the tree, we end up with a considerably large number of steps, and we continue to make the length of each one of these steps narrower, shorter, then we take this tree to a level where it starts resembling the real life, how we expect stocks to move following this random pattern at each passing second. And that's how, when we reach this limit, when we reach this continuous time with stocks having all sorts of possible states, then in prices, then we are getting close to what we will learn as the Black-Scholes model, or in essence, we are getting close to something that converges with the Black-Scholes model that we will see later on. At least this is a sort of a good way of making this a tree and the Black-Scholes model to connect in an intuitive way. I hope it helps, and thank you for your attention.